Unless somebody watches this, how would they know that they need to take these other factors into consideration? What's being done to make the public aware of these changes? I mean, I buy a gasoline-powered vehicle, it's the same as usual. It's business as usual. But electric sounds to be quite a bit different.
Well, this is kind of the exciting thing for the utilities, and that we're working with auto manufacturers right now before these vehicles come en masse into the marketplace. The utilities are working hard right now to help develop standards, like the electric vehicles that were released in the late 1990s, like the EV1 and the Honda electric vehicle, the RAV4 that Toyota put out. And we had all these different types of plug-in technologies. You had inductive charging, conductive charging, and these vehicles, you had all these different ways to plug in. And so wouldn't it be nice to have a standardized plug that would work for all the vehicles? So if there was like public charging, that you could go and be able to plug in your electric vehicle whenever you needed to, and be assured that when you pull into a public charging place, there's something to go there. Things like, where do you locate the plug on the vehicle? If you have plug-in charging at a curb, do you put the plug-in on the side of the vehicle, or do you put it on the front or the back vehicle? We can't have people tripping over wires to vehicles that are probably doing curbside charging. And then back to that problem with a vehicle that would be charging, say, like at a high-rise complex. I mean, will the landlord hook up a special meter and charging plug for that vehicle? Well, one of the things that utilities are looking at right now, a term that you're going to start hearing more of, is smart grid, smart meters, and also working with the vehicle manufacturers to get some types of communications built into the vehicle that's being produced. And that is one of the things we're working on right now with some of the vehicle manufacturers, and it's getting a common language, just to have your house, your vehicle, looked at as another smart appliance. We have these washers and dryers that talk to each other, and the smart grid will be able to communicate. Maybe you might set up your car to charge when the windmills start taking off, the wind energy, and so your vehicle receives a signal through the grid and immediately starts charging, taking advantage of that absolutely clean energy to charge up that vehicle. So we're looking at, the smart meters are basically meters that are going to go in. You're going to set up antennas in the neighborhood, so then meter readers are going away, and the electric company will be able to pull the reads off the meters through antennas and go back into headquarters and be able to do your billing from that. But it's a two-way type of communication. The appliances will be able to communicate with your vehicle. Maybe you'll be able to take your phone and type in a number and tell your vehicle to start charging, or turn on your air conditioning in your house. So there's some really exciting times, and we want to make sure that the vehicles are integrated into all these other intelligent appliances, and that what your car will be is yet another intelligent appliance.
Bad enough that my refrigerator's talking about me. I really don't like car talking about what I do. And the skill, I can imagine one of the first questions my wife will ask me if I decide to do this: is this car safe? I've got 2 young kids. Is this car safe?
Yes, absolutely. The car will not only have to satisfy, of course, all the federal, crash testing, but you have other industries looking at it now. Now that it's an electric vehicle, you got United Laboratories, you got electric standards that are national and state that it has to comply with. And if it has communication technologies, probably FCC will be involved as well. So it has to pass all these battery of tests, no pun intended, to be able to meet all the different safety standards, as well as to secure the plug. I mean, it needs to be safe if you're plugging in the rain. There's all these different things that you have to think about the user, how that vehicle is going to be used, and what are some of the different scenarios. So these are safeties that are going to be built into the product when it comes out, up to including like even a ground fault indicator actually on the plugs of the chargers, so that if there's a ground fault, then it's going to click off. You won't be able to charge your vehicle.
All right, how fast is it going to go?
Oof. Well, you got to.
That sounds good.
Yeah. Well, these vehicles, if you've driven any electric vehicles, they have a lot of torque, and being a product of the '60s, I mean, I haven't ever felt that type of rush, you know, being slammed back in your seat when you're taking off in electric vehicles, until like the vehicles like the EV1 and some of the other electric vehicles. You have a really good takeoff from the start. And just, you know, anticipating this question today, the Tesla can go 0 to 60 in 3.9 seconds. So that's quite a rocket ride, if you will.
How much would it cost me, though?
Well, the Tesla's over 100,000. But again, you know, the electric mode, it's a very efficient design, and where it's just power to the wheels. And so you're going to get some good performance out of these vehicles.
How about the plug-ins? What will they cost me? I mean, I imagine they'll be a little bit more affordable than a...
Right now, we have the Volt is anticipated to be anywhere in the $35,000 to $45,000 price range. With the recent federal bailout package, there is incentive about $7,500 in tax credits from the government, and there is anticipation that there will be more incentives and benefits that could come from not only the feds but also the states. You know, local air districts might even be interested in offering some incentives for these vehicles, as well as possible, you know, high occupancy lane access.
Well, that's one benefit of it. But what are some of the other benefits? I mean, ultimately, is it going to cost me the same to operate this vehicle? Will it cost me less? What are we looking at in terms of, you know, service schedules, cost of service compared to, let's say, a traditional gasoline internal combustion engine?
Let's think about like cost of charge for starters, if you will. It's anticipated that it would take 8 kilowatt hours to fully charge the Chevy Volt. And if you use like our off-peak rates of about 6 cents a kilowatt hour, that will work out about 48 cents to fully charge that Volt. Now, fully charge the battery pack that would carry you that 40 miles. So figure that, you know, 40 cents to, you know, 48, 50 cents to go, you know, say 40 miles. And of course, that's going to be changing different, you know, whatever your utility is at that time. I'm just talking from a PG&E standpoint, using our E9 rate, charging overnight, you know, so there's going to be incentives to take advantage of that low cost power which is usually during the midnight to 6 a.m. in the morning range. So you can take advantage of the rate right there to be able to charge the vehicle. If you aren't using your internal combustion engine, if you're running pretty much on electric vehicle mode, then pretty much you're just using the battery and the electric motors. Electric motors are a very dependable source of energy. You know, they don't require a lot of maintenance. There's not much you can do to them. The batteries are maintenance free. They're a sealed type unit. They're going to go X amount of cycles as far as charging, but that's your biggest investment in these plug-in electric vehicles is the battery packs. But they're being designed to operate for a very long time and shouldn't be a problem.
You mentioned the E9 rate. Will I have two different bills, or will that E9 rate cover all my electricity usage?
With PG&E on the E9 rate, and you can go to pge.com/tariffs, TARIFFS, and look at the E9 rate. We offer two versions of the E9 rate. You have one rate where basically you can just go with 1 meter and basically put your whole house on the E9 rate, provided that you have an electric vehicle that qualifies for that rate, and plug-in hybrid electrics will also qualify for that particular rate. If you choose, say, like the E9 rate is more expensive during the day and you have people living at home using electricity during the day, maybe that might not be as a popular or economical option for you. You can actually opt to get a second meter and basically have a 2-hole meter adapter put in and basically run a dedicated circuit to your vehicle charger and just have your vehicle charged specifically off of that particular meter and be able to charge your vehicle using the E9 rate and take advantage of it from that way. But there is a bit of an expense for that. It would probably run you about, when you think about the permitting, running the dedicated circuit to the meter, anything like that, it'll probably run you about $750 to $800 to be able to get that type of installation put at your home.